In this video, we will learn how to solve exponential equations. So let's look at the first example. 10 to the power x minus 4 equals 34. So let's go ahead and write it down in our column. Now to solve such an equation, the first step is to isolate the exponential. So let's highlight that in order to remember that we need to isolate the exponential. That means that we have to keep 10 to the power x on the left side of the equation, and we have to move negative 4 to the other side of the equation. We do that by adding 4 to both sides. Now 10 to the power x is equal to 34 plus 4, which is a 38. Now moving forward, there are two methods to solve something like this. I'm going to start with method number 1, which is basically to take the log of each side of the equation. That means you put log in front of the 10 to the power x and put a log in front of the 38. Now, you look closer at 10 to the power 6 and you see that there is a power. So the main reason for me to put the log on both sides of the equations is for me to use the power property and move x in the front of the log. So let's do that. It becomes x log 10 equals log 38. Now to get x by itself, you see what I did now? I can just divide by log 10 and x is equal to whatever log 38 divided by log 10 is. So let's divide both sides by log 10. And now I can see that x is equal log 38 divided by log 10. That is one of the methods, which is basically taking the log of both sides. After you isolate the exponential, you take log of both sides and then use the power property to move x in front of the log, then divide by that log, and then x would be by itself. Now if I look closer at this, I can see that I can use a formula called the change of base formula, which basically means that I can rewrite this whole fraction as a log with an argument of 38 and a base of a 10. This is called the change of base formula. Now if the base is 10, I don't really have to write it, then the x is going to be equal to log 38. That is the first method, and it's called taking log of both sides. Now method 2 is pretty simple and straightforward if you know how to change between the two forms, the log and the exponential form. So for me to be able to do the second method, I would like to review with you how to change between log and exponential. Now I want you to remember that the subscript on the g, that's called the base, and the argument is going to be whatever is inside the log, and that's going to be equal to an exponent. So for example, if I have log base 6, 7, let's say, equal, let me change that a little bit. Let me put a 36 on the inside, 2, then I can change that into an exponential, remembering that 6 is going to be my base, 2 is going to be my exponent, and then the answer of 6 to the power 2 is going to be 36. Now, if you know how to change between a log and exponential easily, then I do suggest that you use the second method. So how would you do the second method? Let me just clear this up. Okay. Now, to be able to use the second method, you will have to be able to identify what your base is and know where to put it. So basically change to log form. That's the second method. Okay, so the base is 10, so the number that I'm going to write as a subscript is going to be the 10. The answer of the log is going to be the x, and the argument is going to be the 38. Now let's check. The base 10 to the power x is equal to 38, and that's exactly what I have over here. Now remember, if you have a base of 10, you don't really need to write the numbers. So x is equal to log 38. Simple, straightforward, didn't require lots of properties. There you go. So once you isolate the exponential, you just change it to a log form, and there you go, that's your answer. Now I did it in one step, and I got the same exact answer as before. So you have two choices, either to use this method, which is basically adding a log to both sides of the equation and then using the power property and dividing, or change from the exponential to the log form. Now let's move on to our second example, and let's use method 1 to be able to solve it. So I'm going to alternate between method 1 and method 2 until you find the method that you prefer the best. So I'm going to start now on the second example, which is 2 to the power x minus 3 is equal to 85. Now, as you can see, the exponential is isolated, so I'm going to take log of both sides. And the reason why I'm doing that is because I know that there's something called the power property, and I can move the power to the front of the log, okay? So I'm going to move the power to the front of the log. I'm going to put it in parentheses since I have a minus. And now I need to move the log 2 to the other side by dividing it. Now x minus 3 is equal to whatever this is. Now remember, you can rewrite this as a log of 85 base 2. So the number on the bottom, the log of the number on the bottom, that's going to be your base. Now I need to isolate the x, so I need to add 3 to both sides. So x is equal log base 2 of 85. That's the argument, 85, and then plus 3. That's your answer. Now, I don't know what your teacher requires, but this is an acceptable answer. Or if you would like to have a decimal, then you need access to a graphing calculator. You put this in math, then you scroll down to, so you click on math, then you scroll down to something called log base, and then you will be able to enter the 2 and the 85. And then you add 3 to the answer, and there you go. That's your decimal. Remember always to round to the third decimal place. Now, let's move on to our third example. Now 6 to the power 3x equals 12. I'm going to do now the second method, which is basically not taking the log of both sides, but just changing it to log form. So I need to recognize what the base is. The base is 6. So the subscript of the log is going to be 6. The answer of the log is always the power, and the argument is 12. Now to check, 6 to the power 3x, that's equal to 12, and that's exactly what I have over here. There you go, done. Now divide both sides by 3. And remember, when you divide by 3, it means you are multiplying by 1/3. So instead of writing log base 6 of 12, you can write 1/3 log base 6 of 12, and that's your x. Quick, simple, to the point. This is a good method if you know how to change to log form, okay? Now let's move on to the fourth example. Three times half to the power x plus 4 equals 19. Now remember, you need to isolate the exponential, so you start by subtracting 4 from both sides. So you end up having 3 times half to the power x equals 15. Now, a common mistake that a lot of students do, they multiply 3 and half and end up having 3 over 2 to the power x. Now that is incorrect because half is a base. It has a power x. So you cannot multiply 3 times half. To get rid of the 3, you can divide both sides by 3. So half to the power x is equal to 5. Now, let's use the second method, which is basically changed to log form. So the base is half, so I put it as a subscript. The inside of the log is going to be the argument 5, and that's going to be equal to the exponent. Because a log basically means what is the exponent of half to give you a 5. So when you're looking for the log, you're looking for the exponent. That's why the log always gives you the exponent. There you go. We just solved for log, for x I mean, and that's going to be your final answer. Now let's move on to number 5. 6 to the power 3x minus 9 minus 10 equals negative 3. Now we have to isolate the exponential, so add 10 to both sides. So 6 to the power 3x minus 9 is equal to 7. Now let's go ahead and use the easier, faster method, which is basically changing it to log. So log base 6 of 7 equals 3x minus 9. Now remember, you have to isolate the x to solve it, so let's add 9 to both sides. So you end up having log base 6 of 7. Now remember, you cannot add 7 and 9 because 7 is the argument of the log. So you just set plus 9 as a separate thing. Now equals 3x. Now you need to remember to divide everything by 3, including the 9. And this is what students sometimes forget to do. They just put 1/3 in front of the log or divide the log by 3, and they forgot to do the same thing to the 9. You have to divide everything in the equation by 9. So you end up having 1/3 log base 6 of 7 plus 9 divided by 3, that's a 3, equals x. And there you go, that's your x. Now that's an acceptable answer unless you have a graphing calculator. Now you can put this in your graphing calculator and you're done. Remember, to get to the log base 6 of 7, you can go to math, scroll down to log base, put in the 6 and the 7, and then you can add 3 or multiply that by 1/3 and then add 3. That's how you can get your decimal, but this is an acceptable answer. Now let's move on to number 6. 19 to the power x plus 4 equals 3. Now I would like to do the first method just like so you would have a good practice on both of them, and then you can make your decision. Now as you can see, the exponential is isolated, so I'm going to do the first method, which is basically to take the log of both sides. Now this is also a very good method because it shows you the process. Now you can move the exponent down using the power property, so x plus 4 log 19 equals log 3. Now what you do next is you divide by the log to try to get the x by itself. Now you will have x plus 4 equals log 3 base 19. So remember, the log on the bottom of the fraction will give you the base of the log. Now to get x by itself, you subtract both sides by 4. So you end up having x equals log base 19 of 3. Now remember, you don't subtract 3 minus 4. 3 is the argument of the log. You cannot touch it. Minus 4, and that would be your final answer. Now I do hope that this video was helpful. Please make sure that you practice and do some questions off of the practice sheet.